Hello. Good afternoon.
Good afternoon, sir.
Okay. Let us wait for 1 or 2 minutes more if other could join. Otherwise, we'll start. So, all of you can see the PPT slide.
Yes, sir.
Okay. See, this practical is very important and also very easy if you pay attention. Just uh, few points you have to remember in mind in order to solve the problem of this kind. Okay. So as you know that there will be 3 or 4 drawing sheets. One drawing sheet will be based on velocity analysis by ICR method, which we are going to see today. The second one is velocity analysis of mechanism by relative velocity method. Okay, that is a different method. Third one is the acceleration analysis. It is again by the relative method. So in this practical today, we will first see the velocity analysis in mechanism by ICR method, which is the full form of which is instantaneous center of rotation method. We will see what is this ICR. Okay. So what do you mean by the velocity analysis in mechanism? Okay, as the name suggests, we are interested in velocities of different links. Okay, these velocities may be angular velocity or maybe the linear velocity. So if we talk about the linear velocity, we are interested in linear velocity of different points which are present on the different links of in any mechanism. Okay, so next slide. Which methods are there to determine the velocity of a point on a link? So in practice, there are many methods which can be used to do the velocity analysis. But in our subject, okay, we are limited to our syllabus. In that, we have these two different methods. First is instantaneous center method, and second is relative velocity method. So in exam, the problem may be asked on any of these two methods. It is specified in the problem that which method you need to follow for the solution of the problem. Okay. So first we will discuss the instantaneous center method. Okay. Now we consider the motion of the link AB here in this diagram. Okay. So initially the link AB is here. Okay. Now say after some time the link AB moves and it goes to the new position A1 B1, right? Okay. So we can say that there is motion in the link AB, and we can uh, divide the motion of the link AB in two parts. Like we can say that first link AB has moved to the position A1 B dash, this position like this. Means initially linear motion took place. Okay. Initially what happened? That link AB moved linearly and it went to the position A1 B dash. And at this point, the link AB just turned, okay, just turned about the point A to the new position, that is the final position A1 B1. So generally the motion of the link is the combination of the linear motion and the rotary motion, angular motion. Okay. Other way, we can also consider the motion of link AB in like this. Like first the link AB turned through angle theta to a different position, say A dash B dash, and after that it moved linearly to the next position A1 B1. Final position being the same. Okay, so what generally this ICR method says is ICR method says that irrespective of type of motion, linear or angular, okay, irrespective of that, any motion, any motion can be considered as purely rotational motion. Okay, even if a point is moving in a straight path, we can assume that motion to be that point is moving in a circular path. We can assume that with suitable parameters. Okay, for example, in this case only, if I assume that link AB has only rotated, then you will ask that, sir, a rotational motion has some center of which is called as center of rotation. So about which point it has rotated, about where is the center point. So just I am showing you, it can be located by joining the initial and final positions of the points, like this line. Then you draw a perpendicular, to the line A1, like this. Then you join the initial and final position of point B with line, and from the mid of this, you draw another perpendicular line. Okay, so where these two lines will intersect, there you will get a point which will be the center of rotation. Okay, so it is called as ICR, instantaneous center of rotation. Got it? So why it is called as instantaneous? Okay, because it is the center of rotation for this particular instant only. Okay, sometimes after, what can happen, after some time the link B, link A1 B1 may be in this position like this. So B1 is here and your A1 is here. Okay, so when it traveled from point A1 B1 to say B2 A2, that time it also rotated about some other point, and that point you will see that it will be somewhere here on upward side. Means you will say that center of rotation has now changed, and this center of rotation was there only for that instant. That's why this is called as instantaneous center of rotation, as it changes instant to instant. Okay, so what point to be taken from here? That any motion can be considered as a rotational motion. Even if it is a pure linear motion, that pure linear motion can also be considered as pure rotation. Okay, and then we can do the analysis using the formulae of the circular motion, rotational motion. Okay, which formula we use to for the circular motion? We have this formula, that velocity of any point which is moving along the circle is equal to radius multiplied by angular velocity, v equal to r omega. Okay, so did you understand the what is the meaning of ICR, then rotational motion? Got it? Okay, then I will move forward. Yes, sir. So how we locate the ICR? Okay, so we can consider the motion of link AB as rotational motion about this point, center of rotation, which is called as ICR. Okay. Then what are the properties of the ICR? So a rigid link rotates instantaneously relative to another link at the point of ICR for the configuration of the mechanism considered. Okay. So what it says, that for two links, right? For two links, you can define one ICR. And what is the uh, property of that point for those two links? About that point, one link will rotate. One link will rotate with respect to another link. Okay. So, for example, just for example, okay. So, it is one link. Say it is connected to another link at this point. One, it is link two. So I can find a point. I can find a point ICR which will be at their connection, pin connection. So about this point, one link can turn or rotate about second link. Okay. So this particular point I will call as ICR I12. Okay. Are you getting the means an ICR is the point for two links, right? For two links. And about this point, one link will turn with respect to another link. That is the meaning of it. Now, these two links not should not be necessarily connected. Okay, like link may be like this also. One link is here and one link is here. For example, I will draw complete mechanism. Okay, say it is the fixed link and all other links are moving. So say it is link 1, link 2, link 3 and link 4. So you consider any two links which have the relative motion. So the link 3 is also moving with respect to link 1. So it is possible to find out a point, you know, it is possible to find out a point which we will call as I13. Okay, and about this particular point, the link 3 will have a pure turning motion about the link 1. We will see how to do that. It is not very obvious. We have to imagine it. We have to imagine it. Okay, we will see all this. Then the two rigid links have no linear velocity. Okay, there are two velocities. One is linear, one is angular. Angular means circular, rotational. So no linear velocity relative to each other at the ICR. So at this point, the motion between two links is purely rotational motion. Okay, therefore there will not be any linear velocity. When we will be solving, you will find it very simple to solve the examples. Just few points you need to remember. Okay. Okay. Now you can also note down this formally. Okay, because it will be required. So in a mechanism, there are number of links, right? And we are defining ICR for any two links, any combination of two links. So in such a scenario, how many ICRs are possible in any mechanism? Okay, so you can easily say that number of combinations of the links you can make in a mechanism, okay, will be equal to the number of ICRs. For example, suppose there are 4 links. Okay, so how many combination I can make? So I can make a combination of link 1 and 2. It is one combination. Then link 1 and 3, link 1 and 4. Okay, so for every combination one ICR will exist. So how to calculate the total number of ICRs. The formula is there. Number of ICRs is equal to small n in bracket n minus 1 upon 2, where n is what? Small n is number of links in the mechanism. You have to count how many links are there, put here, and you can then find out how many ICRs are possible there. Okay, understood this point?
Yes.
Okay, you can note it down somewhere in notebook. Okay, because will be required in later part. Okay, now see. Now types of ICRs we will see. That how many types of ICRs are there. So generally there are these three ICR types: fixed, instantaneous centers, okay, which are related with your fixed link. Okay, suppose there is one fixed link and whichever other link is connected to the fixed link. So at their joint, the ICR will be fixed ICR. We will see that type. Second one is permanent instantaneous centers. And third is which is neither fixed nor permanent. Okay. So let us see here. Now here it is a 4-bar mechanism. It is a 4-bar mechanism. So number of links here are 4. Number of links are 4. So if I use this formula, capital N is equal to small n into in bracket n minus 1 upon 2. So I can find out how many ICRs are there. So if you put the value of small n as 4, what is the value of capital N? Capital N कितना होता है?
60.
Yes, loud.
6.
6, correct. So 6 ICRs are possible. Okay. So how to locate? We know that ICR can be found at the joint, pin joint of 2 links. So for example, say I have numbered 1, 2, 3, 4. So where link 1 and link 2 is connected with the help of pin joint at this point. Okay. So I will say it ICR I12. Okay. Then where is another pin joint? So here is the pin joint where link 2 and link 3 is connected, right? So at this point, the ICR for link 2 and 3 will be there. So I will call that ICR as I23. Then link 3 and link 4 is connected at this point. So here I34 there. So at this point, link 3 will turn with respect to link 4, right? Link 3 will turn with respect to link 4. And again, link 4 is connected at to link 1 at I14. So these 4 ICRs I could easily find. Very easy to find. Okay. But to find the ICR I13 and ICR I24, I need to follow some rules. I need to do some geometrical construction in order to find these. Okay. So which ICRs will be known as fixed ICRs? The ICRs which are on fixed link. or fixed link will be known as fixed instantaneous center. For example, here you can see link 1 is fixed. So ICR I12 and I14 will be known as fixed ICR. Now they will not even change their position. Okay, after some time, what will happen? Some say you are giving some input to some bar. As this bar will rotate, all other points will again change. Means this point will move forward, this point will move downward, like this. But these points I12 and I14, they will not change even their position. Okay, that's why they are called as fixed instantaneous centers. Next is permanent instantaneous centers. Okay, so permanent instantaneous centers, though they change their position, okay, from position to position, okay, but they can easily be cited. You can easily say that where those points are. Okay, you don't need any special geometrical construction in order to locate these points. For example, you see I23. For sure, you know that this point will be at the connection of link 2 and link 3. Okay, so if even if this link 2 moves forward, okay, and goes to new configuration, there also you can locate the I23 at the joint between these two. So I23 and I34 are your permanent instantaneous centers. Okay, got it? Okay. And next are the neither fixed nor permanent instantaneous centers. So to find out these uh, instantaneous centers, okay, you have to do some geometrical construction. You can see that I have extended some lines, okay, and located this ICR I13 and I24. So these ICRs will be known as neither fixed nor permanent ICR, and in order to locate them, you have to do these geometrical constructions. Then you can locate this I13 and I24. Okay. So I think you now got the idea about this.
Yes, sir.
Now see the location of instantaneous centers in certain situation, in certain cases, you will observe two links and you can directly say that where will be the ICR. Okay, just by observation it is possible to locate the turning point, the center of rotation, the point where one link is turning with respect to other link. Okay, so these are the very common cases. For example, link 1 and link 2, they are connected here with the help of pin joint. You can say that it is link 2 will turn, link 2 link 2 will turn with respect to link 1 at this joint, pin joint. So I will call this point as I12. Okay. Next case, you see one horizontal surface is there and one coin is there. This coin is rolling on the surface. So can you tell me about which point this coin, which is linked to or this is turning with respect to link 1? Where is the turning point?
Yes, sir.
Okay, where it is? See, so at the point of contact here, you can see at the point of contact, you will see that the link to disk is turning with respect to link 1. So this point will be known as I12. Okay. Next, it is a very special case. Link 1 is fixed surface and a block is sliding. Okay, a block is sliding on this. So first of all, you will see that it is completely linear motion. There is no any rotational motion. So there will not be any ICR. Okay, but already we have stated, okay, we know that any motion can be considered as rotational motion. Okay, so in this case, when there is completely linear motion, sliding motion, then where will be the ICR? ICR of link 2
At infinity.
with respect to link 1, it will be at infinity. I12 will be at infinity. Okay, I will again elaborate this why it is at infinity. Okay, and in which direction? So in the direction perpendicular to the velocity of any point on the link. See. Okay, so in this direction it will be at infinity. Okay, now you consider uh, a car is moving on road. Okay, so which which type of motion is there in car? Is it a linear motion or rotational motion?
Linear.
Car is moving in linear path or in circular path. Okay, answer
Linear.
Sir, linear, sir.
linear, right? Okay, and we have said that any motion can be considered as pure rotational motion. So suppose if the car is moving on road surface, so no doubt it is on earth surface. The car is going on earth surface. Okay, so on earth surface, when it is moving on earth surface, earth is circular. Okay, so we can say that car is moving along a circular path. It is making rounds over the circular path, right? Okay, means car has some rotational motion. Why we didn't realize that it is rotational? Why we told, why we thought that it is only linear motion? Because in this case, the radius of the earth, radius of the circular path is so high, okay, as compared to us, that we could not see that it is moving along a circular path, right? Similarly, this linear motion, if we assume that radius is infinity, means we are at a distance. Okay, we are at a distance equal to infinity, and we are observing from that particular moment. So it will appear to us that this particular object is moving in a circular path, Are you getting or not?
Yes, sir.
Okay, so it is a particular case. You remember that if an object slides in a linear path, its radius or its center of rotation lies at infinity in a direction perpendicular to the direction of velocity. You have to remember this in order to solve few problems. Okay. Then coming to this next case D, where link 1 is a curved path, and over in this curved path, this block is sliding like this. So as the block is sliding in a curved path, we will say that the block is rotating about some center of rotation. And where will be that center of rotation? That center of rotation will be the center of this curved path, this curvature. So you locate there, there you will find I12, and you can then say that about point I12, this block is sliding, this block is rotating, sorry, this block is rotating. Similarly, you see this E. Now here this block is sliding on convex surface of the circular path. So no doubt this block is rotating. You see this block is rotating about this center, which is the center of this circle. Okay. So this is very important to understand what is ICR. ICR is nothing but center of rotation. Okay. Only why we call it instantaneous, because in many for many links in the mechanism, it keeps changing. Okay. Because when the position of the different links of the mechanism will change, ICR location of ICR will also change. Okay, so this is about this. Okay, if we get logged out, okay, you have to join back immediately. I will continue to. Okay, it is also important. Aronold, Kennedy, or three centers in line theorem. It is useful to you in order to locate the other ICRs. Other ICRs in the sense those ICRs are generally not required for calculation. Okay. So, but in some problem it is asked that locate all the ICRs. That time you will use this Kennedy theorem. Okay. What it says, if three bodies move relatively to each other, okay, they have three ICRs, three instantaneous centers, and those ICRs lie on a straight line. Okay, so here you are considering three bodies. Okay, so suppose the link A is one body, B is there, and C is there. Suppose they have relative motion between each other. Everyone is moving with respect to every other link, right? Which generally happens in case of mechanism, that every link moves with respect to every other link. That's why it is qualified to be a separate link. Okay. So what it says, that if there are three bodies and they are moving relative to each other, then they will have three ICRs. We know that for every combination of link there is one ICR. So how many combination we can make? So A का B के साथ एक combination होगा, तो उसका एक ICR होगा IAB. एक का combination C के साथ होगा, तो ICR होगा IAC. और B का combination C के साथ होगा, तो IBC. There will be three ICRs. Now next condition, what it says, that all three ICRs will lie on a straight line. All these three ICRs will lie on a straight line. So here, suppose Suppose we have located the ICR IAB here. ICR IAC is here. We know for sure. Okay, then we have to locate where will be ICR IBC. Okay, so by Kennedy's theorem, what it says that all three centers will lie on a straight line. So we should know by sure that ICR BC must be on extension, must be on extension of the line joining these first 2 points. Means ICR BC will not be here. It will be somewhere here on the line which is joining the previous two ICRs. It may be here or it may be here, but not here. This theorem you have to keep in mind in order to find out the location of other ICRs. Okay, if it is asked in examination in numerical that locate all the ICRs, then only you have to locate all the ICRs. From calculation point of view, we do not need all the ICRs of the mechanism. Like if there are 15 ICRs in the mechanism, then we do not need all those ICRs. Okay, for calculation. So if possible, you note it down. Then we will move forward. I will explain. Okay, so third ICR will be maybe here.